Have you ever truly thought about the way you swallow? Aside, maybe it's the sandwich you're working on right now. It is a quiet, rhythmic, and entirely unconscious act. You take a bite, chew a few times, and the food slides down without a second thought. But why is it so easy? Why does your throat work so smoothly, and why isn't every single meal a desperate physical struggle against the very fibers of life? If you tried to eat your dinner today without the intervention of heat, your afternoon would look very different. So, what did we actually do before we learned how to tame the flame? Why does the idea of a raw diet sound like a modern health trend, when for 90% of our history, it was a brutal necessity? How did we survive the pathogens that would kill a modern human in a week? And most importantly, what does our pre-fire menu tell us about the strange, hungry creatures we used to be? The timeline of our relationship with fire is a lot messier than your middle school history textbook probably suggested. To be fair, those books usually skip the million-year gaps where nothing seemed to change. We often imagine a lonely caveman striking two rocks together and instantly transforming into a gourmet chef, but the reality is a vast, yawning stretch of time where we were just another primate eating in the dark. Modern humans, Homo sapiens, have only been around for about 300,000 years. However, our broader genus, Homo stretches back nearly 3 million years. While there is heated debate among archaeologists about when fire became a controlled tool, meaning we didn't just find a burning bush and huddle around it, but actually started and maintained it, most evidence points to a consistent use of fire starting only about 400,000 to 1 million years ago. This creates a massive, uncomfortable question. What were we doing for those first 2 million years? If you subtract the fire, you are left with an evolutionary gap where every single calorie had to be pulled from the world exactly as it was found. How did we bridge that gap without starving? Did we simply spend every waking hour chewing? If you want to understand the physical toll of a raw diet, you have to look at the mechanics of the mouth. Aside, your dentist would probably have a heart attack looking at a 2-million-year-old skull. In 2016, researchers Catherine Zink and Daniel Lieberman published a landmark study in the journal Nature that changed how we think about the pre-fire mouth. They wanted to know exactly how much work it took for an early human to process raw meat and root vegetables. They didn't just guess, they actually had modern volunteers chew raw goat meat and starchy tubers like yams while sensors measured the force of their jaws. What they found was startling. A human trying to eat raw meat without any tools or fire is essentially trying to chew a rubber band. Our teeth are not designed to shear through raw muscle fiber. The volunteers in the study literally could not break the meat down enough to swallow it until they used simple stone tools to slice or pound it first. This suggests that before fire, our diet wasn't just about what we ate, but about the technology we used to pre-digest it outside of our bodies. If we couldn't cook the meat, we had to mechanically destroy it. Why did we develop such massive, heavy jaws if we were just going to use stones anyway? Did the stone tools come first, or did the diet force our hands? This brings us to the chewing paradox. Before fire, a hominin would have had to chew for roughly 5 to 6 hours every single day just to extract enough energy to keep their brain running. Aside, that is essentially a full-time job with no dental insurance. This is what chimpanzees and gorillas do. They spend a massive portion of their lives simply grinding down tough, fibrous plants. But early humans didn't do that. We see a strange trend in the fossil record, starting with Homo erectus about 1.9 million years ago. Their teeth got smaller and their brains got bigger. This is a biological impossibility unless something changed in the diet. If fire wasn't common yet, how did Homo erectus manage to shrink their chewing equipment while increasing their energy intake? The answer seems to be a combination of high-quality raw fat and a very specific type of tool use. By using Oldowan stone tools, the simplest sharp flakes of rock, early humans could slice raw meat into small swallowable pieces. Zink and Lieberman's research showed that by simply slicing meat and pounding tubers, Homo erectus would have needed to chew 17% less often, and with 26% less force. This was the first great shortcut. But if tools solved the chewing problem, what about the invisible killers hiding in the raw flesh? How did we not die from the sheer bacterial load of raw, scavenged meat? Aside, your stomach is actually a lot more aggressive than you give it credit for. When we think of raw meat today, we think of food poisoning. We think of Salmonella E, coli and a host of parasites that make modern life miserable. But our ancestors were not eating in a sterile environment. In fact, many of them were likely scavengers, arriving at a carcass long after a lion or a leopard had taken the choice cuts. This meant eating meat that was not just raw, but potentially beginning to spoil. To survive this, our ancestors developed a biological shield that we still carry today. Human stomach acid is incredibly potent. It has a pH of around 1.5, which is significantly more acidic than the stomachs of many other primates and closer to the acidity of scavengers like vultures. This high acidity acted as a pathogen filter, killing off most of the bacteria before it could colonize the gut. But acidity isn't a perfect shield. Were there other genetic adaptations that allowed us to handle a diet that would be lethal to us today? Researchers like Caleb Finch and Craig Stanford have proposed a fascinating theory involving a specific gene called ApoE4. Aside, it's a gene that is nowadays associated with Alzheimer's, which shows that evolution always comes with a trade-off. They argue that ApoE4 may have evolved as a meat-eater's gene to help early humans deal with the massive inflammatory response and the parasitic load that comes with eating raw, potentially tainted meat. This gene helped manage the cholesterol and the infections that a high raw meat diet would otherwise cause. This suggests that we didn't just change our behavior to eat raw meat, we changed our very DNA. But if we were becoming meat adapted, does that mean we stopped eating plants? And if raw plants are so hard to digest, why bother with them at all? The plant side of the pre-fire diet is even more of a puzzle than the meat. You probably think of tubers, things like potatoes, yams, and carrots as a survival staple. Aside, try eating a raw wild potato, and you will quickly realize why we invented boiling. Raw starch is notoriously difficult for the human body to process. In its raw form, starch is locked away in crystalline granules that our digestive enzymes, like amylase, simply can't crack. If you eat a raw potato, a huge portion of those calories pass straight through you without ever entering your bloodstream. This is the core of Richard Wrangham's cooking hypothesis. Wrangham, a biological anthropologist at Harvard, argues that humans are the only species that cannot survive for long on a purely raw diet in the wild. He points to studies of modern raw foodists, who despite having access to high-quality blenders and processed oils, often suffer from chronic energy shortages. If modern humans can't do it, how did our ancestors manage it for 2 million years? The secret likely lies in the types of plants they chose. Before fire made tubers edible, our ancestors likely relied on fallback foods that didn't require heat. This includes things like wild fruits, which are packed with easily accessible sugars, and nuts, which provide dense pockets of fat and protein. But there is another, more gruesome category of food that often gets ignored in these discussions. Why don't we talk more about the insects? Aside, they are basically tiny, crawling sticks of protein. For a pre-fire human, a termite mound was a gold mine. Insects are nutritionally dense, easy to catch, and require zero cooking to be perfectly digestible. In fact, many insects have a nutritional profile that rivals or exceeds beef. Chimpanzees today use sophisticated sticks to fish for termites, and it is almost certain that early humans did the same. This provided a consistent, safe protein source that didn't carry the same bacterial risks as a rotting elephant carcass. But if insects and fruit were the mainstays, why did we ever move toward the high-risk, high-reward strategy of big game hunting? What if the move toward meat wasn't about the protein, but about the marrow? If you find a bone in the savannah, the meat might be gone, but the yellow gold inside is often still there. Bone marrow and brains are some of the most calorie-dense substances in the animal kingdom, and they are protected from bacteria by the bone itself. Aside, it's like a biological Tupperware container. Early hominins used heavy stones to smash open long bones, giving them access to pure raw fat. This fat was crucial for brain growth, but this leads to a secondary problem: the gut-brain trade-off. In 1995, Leslie Aiello and Peter Wheeler proposed the expensive tissue hypothesis. They pointed out that both brain tissue and gut tissue are incredibly expensive to maintain. They require a lot of energy. Since an organism only has a limited energy budget, you can't have a massive brain and a massive gut at the same time. To grow our brains, we had to shrink our guts. But you can only shrink your gut if your food is easy to digest. This creates a circular mystery. Did we start eating better food to grow our brains, or did our brains grow so we could find better food? This trade-off is visible in the very shape of our bodies. If you look at a gorilla, it has a massive protruding stomach. Aside, it's not fat, it's a giant fermentation tank. That large gut is necessary to break down the massive amounts of raw fibrous cellulose they eat. Humans, by contrast, have a relatively small digestive tract. This transition is clearly visible in the shift from the ape-like Australopithecus to the more human-like Homo erectus. Even without fire, Homo erectus had already begun the process of gut reduction. This suggests that their raw diet was already significantly higher quality than that of their ancestors. They weren't just eating more, they were eating smarter. They were targeting marrow, brains, and perhaps fermented fruits that had already begun to break down chemically. But if they were already doing so well with a raw diet, why did fire change everything? Why was fire the point of no return for our species? To answer that, we have to look at what happens to a human when fire becomes permanent. Fire doesn't just make food taste better. It changes the chemistry of the meal. It denatures proteins, making them more accessible to enzymes, and it gelatinizes starches, turning a useless raw tuber into a calorie bomb. Once we started cooking, the energy available to us skyrocketed. This allowed our brains to enter a period of explosive growth that led directly to Homo sapiens *. But this came at a cost. We became biologically dependent on cooked food. Our guts shrank so much, and our jaw muscles became so weak, that we lost the ability to survive on the raw world. We are the only primate that will starve to death in a forest full of raw food. It is a strange kind of prison to be the most successful species on Earth, yet unable to survive without a stove. There is a final piece of evidence that suggests just how diverse the pre-fire diet really was. It comes from the study of dental microwear, the tiny scratches and pits left on teeth by the food we chew. When researchers look at the teeth of Paranthropus boisei a cousin of our ancestors, they find heavy wear consistent with eating tough, gritty tubers. But when they look at early Homo species, the wear is much lighter. This confirms that we were choosing softer, higher quality foods. We were the generalists of the primate world. We didn't specialize in one tough food. We used our growing intelligence to find the easiest, most energy-rich bits of the environment. We were eating honey, which is essentially pure energy that requires no processing. We were eating bird eggs. We were likely even pre-processing our food by leaving it in the sun to dry, or letting it sit until natural fermentation made it easier to handle. But does this mean the pre-fire diet was healthier than what we have now? Modern proponents of the raw food diet often point to this era as a golden age of human health. They argue that our bodies are designed for this ancient way of eating. Designed is a strong word for a process that mostly involves surviving just long enough to have kids. The reality is that the pre-fire diet was a regime of extreme scarcity and physical hardship. While it prevented many of the diseases of civilization like type 2 diabetes, it did so by keeping us on the edge of caloric failure. The paleo diet of 3 million years ago wasn't a choice. It was a struggle. If you were a pre-fire human, you spent your entire day thinking about your next calorie. You were constantly at risk of parasitic infection, and a single bad season could wipe out your entire social group. Fire wasn't just a convenience, it was a liberation. It freed up the hours of the day we used to spend chewing, allowing us to spend that time thinking, socializing, and eventually, building a world where we never have to worry about the toughness of a muscle fiber again. So, what happens if we try to go back? What does the latest science tell us about our ability to handle the pre-fire world today? Recent studies on the Hadza people of Tanzania, one of the last groups to live a traditional hunter-gatherer lifestyle, show that while they do eat a significant amount of cooked food, they also consume a large variety of raw items, including honey, berries, and even some raw meat. However, even the Hadza rely heavily on fire to make their starchier tubers edible. Their health is excellent, but their lifestyle is not one that most modern humans could maintain. It involves a level of physical activity and a tolerance for environmental pathogens that we have simply bred out of ourselves. We have spent the last million years moving away from the raw world, and our bodies have followed suit. We are now a cooked species, shaped by the hearth and the pot. The shift to fire wasn't just a change in what we ate, it was a change in who we were. It allowed us to move into colder climates where raw food was scarce. It allowed us to develop the social structures that form around a central campfire. It literally fueled the expansion of the human mind. Every time you eat a hot meal, you are participating in a million-year-old tradition that separates you from every other animal on the planet. But it's worth remembering that for most of our journey, we didn't have that luxury. We were the creatures who survived on grit, raw fat, and the occasional handful of termites. We were the primates who learned how to use stones to do what our teeth could not. It's funny how we spend so much money today trying to eat like a caveman, when the real caveman would have given anything for a microwave. The story of the pre-fire diet isn't a story of a lost paradise. It's a story of a biological workaround. It's a story of how a weak, slow primate used its brain to overcome the limitations of its own stomach. We survived the raw world not because we were perfectly adapted to it, but because we were clever enough to start changing it before we even knew how to make a spark. We were already cooking our food with stones and saliva long before we ever used a flame. And as we look at the history of our diet, we see a clear, undeniable pattern. We have always been looking for a way to get more for less, more energy for less chewing, more brain power for less gut, more life for less struggle. But as we sit here in the modern world, surrounded by an abundance of calories that our ancestors couldn't have imagined in their wildest fever dreams, we have to ask ourselves a difficult question. If we are so far removed from our raw roots, why does our biology still crave the high-fat, high-sugar rewards of that ancient world? Why do we still have the stomach acid of a scavenger and the teeth of a tool user? The answer is that evolution is slow, and technology is fast. We are modern minds living in cooked bodies that are still running on software written for a raw savanna. We are a species in transition, caught between a past we can't go back to and a future we are still trying to figure out how to digest. How does this change the way you look at your next meal? If you had to, could you survive a week in the wild without a lighter? What would be the first thing you'd reach for? Would you be brave enough to smash a bone for its marrow, or would you find yourself staring at a raw tuber, unable to unlock the energy inside? It's a question that forces us to realize just how much we've lost in exchange for our progress. We've traded our physical ruggedness for the ability to build civilizations. We've traded our fermentation tanks for our thinking machines. And while that trade has worked out well for us so far, it has made us fragile in a way our ancestors never were. Think about the Hadza again, or the San of the Kalahari. Aside, they probably wouldn't find our survival shows very impressive. They carry an ancient knowledge of the world that we have largely deleted from our collective memory. They know which insects are sweet and which are bitter. They know exactly how to pound a root to make it swallowable. They are the last link to a version of humanity that was defined by its relationship with the raw world. As we lose those cultures, we lose the last living evidence of what it actually means to be a pre-fire human. We are left with nothing but the silent testimony of old bones and the strange acidic secrets of our own stomachs. What if the most important thing fire did wasn't cooking our food, but changing our relationship with time? Before fire, the sun dictated everything. When the light went out, the eating stopped, and the hiding began. Fire gave us the night. It gave us hours of extra time to talk, to plan, and to dream. It turned the act of eating from a solitary, mechanical necessity into a social event. Perhaps the pre-fire diet wasn't just about what was in our mouths, but about the isolation of the dark. When we brought the fire into the cave, we didn't just warm our food, we warmed our species. We turned a collection of scavengers into a community. As we wrap up this journey through the raw era, it's worth considering a final haunting fact about our place in the natural world. Aside, this isn't the kind of thing they put on food packaging. You are a member of the only species in the 3.5 billion year history of life on Earth that is biologically incapable of surviving in its own natural habitat. If we took away the fire, the stoves, the electricity, and the processed grains, the human race would go extinct in a matter of months. We have become a technological parasite on the planet, unable to process the raw bounty of the Earth without an external energy source. You are not a top predator because of your claws or your teeth. You are a top predator because you learned how to use a chemical reaction to outsource your digestion. Every other animal in the forest looks at the world and sees a buffet. You look at the world and see a collection of raw ingredients that are currently useless to you. You are a specialist in the transformed. You are a biological outlier, a creature that has traded its independence for a higher level of existence. And the next time you feel the comfort of a warm kitchen, remember that this comfort is the only thing standing between you and the brutal, 5-hour-a-day chewing marathon that defined your ancestors for 2 million years. You aren't just eating your lunch. You are consuming the legacy of a fire that was lit 1 million years ago and has never been allowed to go out. Which part of this ancient menu surprises you the most? The idea of chewing raw goat for 40 minutes, or the thought of insects as a gourmet staple? Does knowing about your scavenger's stomach change how you feel about your own body? Let me know your thoughts in the comments, especially if you've ever actually tried a raw diet and felt that ancestral energy, or just the ancestral hunger. If you want to keep digging into these evolutionary rabbit holes, subscribe and join us as we continue to unearth the weird, messy history of how we became human. But as you go back to your day, don't forget the reality of your own anatomy. You are a specialized, fragile machine, a biological prisoner of your own inventions. You are a primate that has forgotten how to be an animal, a creature whose very survival depends on a technology it can no longer live without. The raw world is still out there, cold and indifferent, but you have lost the keys to its pantry. You are the only living thing on this planet that can starve to death with a full stomach simply because you don't have a way to turn it into heat. You are the master of the flame, but without it, you are nothing more than a memory waiting to happen.